Every single planet we know, Earth, Mars, Jupiter, even those in distant galaxies, began the same way as simple dust floating in the vastness of space. So how do these tiny, microscopic particles come together to create entire worlds? Let's journey back in time and uncover the incredible story of how solar systems are born. Welcome back to Understanding the World. Today, we're diving deep into one of the universe's greatest construction projects, the formation of planets. We'll explore the epic process from cosmic dust to fully formed worlds and discover why our own solar system turned out the way it did. It's a story of gravity, collisions, and cosmic architecture. It all starts with the birth of a star. Imagine a colossal cloud of gas and dust, so large it stretches for light years. Over millions of years, gravity begins to pull this cloud inward. The center gets denser and hotter until a new star ignites, a protostar. This baby star is surrounded by a massive, spinning, flat disk of leftover gas and dust. This is the protoplanetary disk, the cosmic nursery where planets are about to be born. Everything needed to build a solar system is right here in this swirling disk. Inside this disk, the real action begins. Tiny dust grains, smaller than grains of sand, start to bump into each other. Thanks to static electricity and other forces, they stick together like dust bunnies under your bed, but on a cosmic scale. These clumps grow from dust to pebbles, then to rocks, and eventually into objects kilometers wide. This gradual buildup is called accretion. These early building blocks, the first seeds of future planets, are called planetesimals. Think of them as asteroids in the making, the raw material for world building. Now that we have these planetesimals, gravity takes over as the main construction manager. The biggest planetesimals have the strongest gravitational pull, and they start attracting smaller ones. Collisions become more frequent and more dramatic. Over millions of years of this cosmic demolition derby, these planetesimals merge and grow into larger bodies called protoplanets, essentially planetary embryos. Where these protoplanets form makes all the difference. Closer to the young sun, where it's warmer, only rock and metal can survive the heat. This is where rocky planets like Mercury, Venus, Earth, and Mars are built. But in the colder, outer regions of the disk, it's a different story. Protoplanets there can grow much larger and gather not just rock, but also ice. Their powerful gravity pulls in massive amounts of gas from the surrounding disk, creating the gas giants like Jupiter and Saturn, and the ice giants, Uranus and Neptune. Once a planet has grown to its nearly final size, it becomes the dominant force in its part of the solar system. It enters a clearing the neighborhood phase. Like a gravitational bulldozer, it either absorbs any remaining debris in its path or uses its gravity to fling it away into deep space. This chaotic but crucial process is what sculpted our solar system's final layout. It's why we have the rocky planets nestled close to the sun, the gas giants reigning over the outer regions, and the leftover rubble organized into the asteroid belt between Mars and Jupiter, and the Kuiper belt beyond Neptune. But what about all the material that didn't become a planet? Not every piece of the puzzle fits perfectly. These leftovers are just as fascinating. They became the moon's orbiting planets, the countless asteroids and comets that wandered through our system, and dwarf planets like Pluto. These celestial relics are like time capsules. Because they haven't changed much in billions of years, they hold precious clues about the conditions of the early solar system, making them invaluable targets for scientists to study. So from a swirling cloud of dust to a family of diverse and magnificent planets, the birth of a solar system is a story of cosmic chaos, epic collisions, and immense stretches of time. And the most exciting part, right now, across our galaxy, thousands of new stars are lighting up, their own protoplanetary disks are swirling, and new worlds are taking shape. Which planet's origin story should we explore in more detail next? Let us know in the comments. If you enjoyed this journey through space and time, please give this video a thumbs up, subscribe to Understanding the World, and hit the bell so you don't miss our next simple explanation of complex science. Thanks for watching.